one example. In the expanding universe, we are told, and I have to believe it, that everywhere is, as it were, the same as everywhere else. There's no one place which is the edge of the universe. How can that be?
Well, Richard, first of all, you said you're told it, so you have to believe it. I will never require you to believe anything.
Good for you. Well done.
It will only ever be about how compelling is the evidence to you. But you started with our sensory organs and landed in the expanding universe. Can I take us back to the organs and then perhaps land in the universe?
Yes.
The urge to think of our senses as being powerful or good is strong because first, that's all we have. Second, we like having nice thoughts about ourselves rather than miserable, depressing thoughts. So we're prone to walk around celebrating, for example, the power of sight or of taste or of smell. When, of course, when you really want to smell something, you bring a dog and their nose smells much better than your nose smells. I was going to say the dog smells better than you, but that would insult you. So their nose smells. So we already know that our senses are feeble, and we reach to other creatures in the animal kingdom, cite them as having better examples of our sight, of our taste, of our smell. But little did people know much before a century and a half ago that our sense of vision is limited only, as Richard said, to the colors of the rainbow. And it's quite extraordinary to realize that, for example, beyond red, there's something called infrared. And beyond infrared, there are microwaves. And beyond microwaves, there are radio waves. Go the other direction, you go beyond violet, ultraviolet. Beyond that, X-rays, gamma rays. Energy goes up as you approach gamma rays, with dramatic consequences if you have gamma ray exposure, by the way. Of course, we all know you turn big, green, and ugly, as the Hulk had experienced. But the point is, the visible light part of that spectrum is a tiny slice, and the universe doesn't only communicate with us through that slice, as we had taken for granted for so long. Most of the history of the telescope, which is itself an extension of our eyes, extended the power of our eyes, but not the range of our eyes. And it wasn't until we first understood maybe we're missing something in the 19th century. The 20th century came decade by decade, new telescopes in each newly discovered band of light. And only then did we learn about black holes in the universe or remarkable, violent forces operating in the centers of galaxies discovered by radio telescopes. So, yeah, we're practically blind out there, and it's humbling, by the way, but that's the whole point of the methods and tools of science, to not only extend your senses in the domain in which you understand, but to take them to places they've never been before. On top of that, we have methods and tools that detect things that are not even extensions of your senses. You have no clue what the magnetic field is around your body right now. You have no clue whether or not you're being bathed in ionizing radiation right now. You'll eventually figure that out as limbs start falling off, but while it's happening, you actually don't know. And there are other things that are more subtle, like polarization of light. So when I think of the scientist's toolkit, especially the astrophysicist's toolkit, it's all about how many different senses can you bring to bear, technological senses can you bring to bear on decoding the universe. One of the things we've discovered, now getting to your horizon question, we look around the universe and it looks like we're in the center. What an ego-supporting concept that is. You can either go around continuing to think that, feeling good about yourself, or study the problem and learn that in an expanding universe where the speed of light is finite at 186,000 miles per second, forgive me using miles per second.
I prefer miles.
You do? You got that on tape? You're an Oxford professor.
No, it's true. Nobody talks about kilometers in Britain.
Oh, good. All right. So we share not only most of our language, we share miles still. And inchworms, what do they call them? They're not centimeter worms, right? They're inchworms.
We don't have that sort of stuff in Britain. That's Europe.
Of course, Britain is not Europe, as we're constantly reminded. That's why here we have the English breakfast and the continental breakfast.
Yes, that's
They're
right.
very different breakfasts that you can order here. So this horizon problem is actually quite simple. And rather than explain the full-up nature of it, let me just give a simple example that is entirely analogous. When you're a ship at sea and you look out, your horizon in every direction is the same distance from you. It depends on your height above the sea level. That's why ship decks are high. They see farther beyond the curvature of the earth than you do just standing on the main deck. So your horizon is a perfect circle centered on you. You can conclude that is the extent of the entire earth, or you can imagine, suppose I'm in another spot. Well, that horizon is still true for whoever happens to be in the middle of it, but now you've moved to a new place, and you will see a horizon corresponding with that spot. And so everybody has a horizon at sea, yet no one at any time is thinking that that's the full extent of the ocean or the full extent of the earth. We have a horizon in the universe, so does the Andromeda galaxy. The galaxies with names that look like phone numbers. If you travel to those galaxies, they will see the edge of the universe now in 3 dimensions, in every direction, at the same distance from them, just as we see for ourselves.
That does it for me, provided that the horizon is that which we are capable of seeing. I could follow that if you said that for any part of the universe, the horizon is the bit before the expanding universe has disappeared over the horizon.
Yes.
Which means it's no longer visible.
Yes.
No longer, but it's still there, even though we can't detect it.
It's true with the ocean when you're at sea.
Yeah, but is anybody on my side here?
You want it to be a harder problem than it is. I'm just simply saying, so here you go. The radius to our horizon is about 14 billion light years.
Got it, okay.
Okay?
Yeah.
If we sat here or returned to this spot 1 billion years from now, that horizon will be 15 billion light years away.
Yep.
It's actually an expanding horizon because the light from 15 billion light years away, will have had time to reach us. Right now, it's still en route.
Yeah, I have no problem with that, but beyond the 14 billion year...
The problem is the universe wasn't born yet.
Yeah, okay.
That's the problem.
I know.
Okay? So you can't see the universe before it existed.
So why doesn't somebody...
Invent a kind of telescope that can?
No. Okay, I'm getting out of my depth here. Let's get back to...
No, just to clarify.
Okay.
Just to clarify. So it takes light time to reach us, and the universe hasn't been here forever. When you combine those two facts, you get an edge of the universe. And so the universe has been here for 14 billion years. The farthest thing that could send us any information is 14 billion light years away.
I get that, but what about the guys who are on the edge of what we can see? How can they see beyond the other side?
Oh, because here's an interesting point.
Okay.
We don't know whether or not the entire universe is infinite.
Okay.
And our horizon is, the universe could be twice our horizon or infinitely larger than our horizon. Same with the ocean. You don't know how much bigger the ocean is than your horizon is. You can keep sort of wandering around. Maybe you'll hit land, as we've done, of course. So now you go there. If the universe is really, really big, that will be the center of their own horizon. And whatever the age of the universe is for them at that time, that will be the radius to their horizon.